I can say, because I was there when Cassini arrived in late 2004, and 2005.
The heat shield has not burned through. It has held on and has protected the Huygens probe, and the parachute has deployed, and this is the carrier signal telling us that now there's communication between Huygens and Cassini.
When we saw the first images that came back from the camera on board Huygens, we saw immediately that none of our models, none of our predictions, nothing in our imagination had prepared us for the diversity that we saw really on Titan's surface.
I was there, so this was one of the most memorable moments in my career, I would say. Assuming that all goes well and we get the science data, I think Titan is such a fascinating world and Huygens is so well equipped to study it that we will remember this day as we remembered Voyager. I was there with about a dozen other people, and when the data finally came into the terminals in that trailer, it was in the form of hundreds of thumbnail images.
The parachute opened from the Huygens probe around 100 miles above the surface, and then it was able to descend, kind of swaying slightly from side to side under its parachute, and actually ingest part of the atmosphere as it descended and kind of sniff these chemicals and determine some of the constituents of the atmosphere. And then it took images, especially as it got closer to the surface, around 15-20 miles up, was able to see not only icy mountains, but kind of carved river channels where there appears to have been ancient flowing rivers of methane on Titan's surface.
There were river channels on a hillside, river channels on this cold, distant, icy moon.
It was really dramatic. We didn't quite know what to expect. In fact, the Huygens probe was designed for multiple different types of surface landing. It was designed even to float if it landed on a sea or an ocean. But as it turned out, it landed on a dry surface, thought to be kind of a bedrock of water ice, but covered in a hazy material which has drifted down from the surface.
And those channels evidently were carved by liquid methane because the temperature was far too low for liquid water. And I remember when I saw those just screaming because that was the kind of thing that we're actually looking for. But it was for a while, for about an hour, there were about a dozen or so of us who were the only human beings to have seen the surface of Titan up close until finally other people started coming into the porta-cabin and sharing our joy. So that was really, that was an amazing experience to see for the very first time the surface of an alien world that was shrouded with haze and clouds. So we couldn't get a good view of the surface by any other means. And finally to know what was there and to see that there was a kind of an active meteorology and geology somewhat analogous to that of the Earth.
And when Huygens landed on the surface, it was able to take the first images of the surface and see kind of pebbles of water ice strewn around the surface. It looked like kind of like an icy desert.
The lakes and the mountains and the channels and the dunes and all of those regions and areas that remind us of what we have on Earth, but with completely different materials. And we were all like, is this Titan? Is this really Titan? Because we had imagined it for so long, but we had never gone into as much detail as that. So that was the moment when Cassini, the orbiter, and Huygens, the probe, came together and sent us all the data back in 2004 and 2005, that we first began to comprehend the complexity of Titan's system.
So Titan's a really exciting place, and just because we sent the Cassini-Huygens mission there does not mean that we have all the answers already. In fact, there are many questions raised by the mission that we still need to answer. Some of those pertain to the chemical complexity of the atmosphere. Does it create chemicals which could be the seeds of life? There's also many questions about Titan's weather, and why is it that there are lakes and seas only in the northern hemisphere and not in the southern hemisphere? There's also questions about Titan's interior. Does it harbour a vast interior water ocean, and could there even be a life inside Titan as well as on the surface? So really many outstanding mysteries.
So what James Webb Space Telescope is able to do for us is to continue the observations over a longer period of time.
JWST now, which is an amazing tool that people think only looks at galaxies and stars, but we use it for planetary investigations. JWST is going to get us so much more information on Titan and this kind of small bodies that are very far away from the Earth. We need big telescopes, and We are discovering a lot of new things about the composition of the atmosphere and the surface every day. JWST is helping so much.
The giant planets, though, have their own retinue of moons, some of which, turns out, have liquid water under their surfaces. So this makes for a very rich system where there might be environments where life perhaps could exist beyond the Earth. So one of the outstanding questions, and one that Webb can help us answer, is whether there are habitable environments in the outer solar system, in the moons of the outer solar system, that we can study up close and perhaps even find evidence of life.
It's just been wonderful to watch the new data come in, and also equally wonderful to watch the teams working together to try to figure out what it means, like the Titan team.
Okay, great. Well, again, thanks for allowing me to speak at this exciting JWST first year workshop.
Well, congratulations to the whole team. It was a work of many, many people to help with all these integration times and settings and team effort since, I think, 2016 when we first submitted this. Yeah, it seems like there was some excitement this morning. Everyone logged in their computers and got some pictures of Titan. It's almost like being back in Cassini all over again.
And they get this JWST data, and it's just like, whoa, look at this. And watching them kind of argue over things and like, well, no, it can't be that. Well, I think it might be. Let me check this. It's really fun to watch that all been happening. And that's been happening sort of across the solar system.
So the Webb telescope, unlike the Hubble telescope, views in longer wavelengths. That's what we call the infrared, or the getting into the heat part of the spectrum. And because of those longer wavelengths, Webb is able to penetrate to different depths in the atmosphere compared to Hubble. And that reveals different layers of the atmosphere. So using the Webb telescope, we've seen clouds at different altitudes coming and going. We believe convecting, possibly even raining out on the surface.
Seeing really fantastic detail here on Titan from these processed Webb images from November. Our very first look at Titan from the Webb telescope. There's this vast dune field here called Ballette, which is a hydrocarbon sand dune field on Titan's lower latitudes, like a vast desert. And then in the northern regions here, we can see these two really large cloud events that are really going off here, close to where the lakes are located, the famous methane lakes of Titan.
We've also been able to use a Webb spectrometer, which is a part of the instrument that can split apart light into different wavelengths or frequencies, and has been able to tell us a lot about the chemical composition of the atmosphere that we didn't know previously, including we can now see Titan's methane actually breaking apart in action and forming into new chemicals. We've been observing Titan with Webb now for almost 2 years. We're expecting to get new observations this year, which should reveal if there are changes in the seasonal weather patterns, if the clouds are moving from where they are right now in the mid-northern latitudes and moving towards the equator to the south. We're very excited for next year when there may be equatorial storms, such as we're seeing with the Cassini mission around 15 years ago at the last equinox. So it'll be a really exciting time to observe and see if there are these big storms coming back on Titan.
From space with JWST, we detect new things. We find new molecules because we have the technology improved. But there is absolutely nothing in my mind that would compensate or be a substitute for further exploration of Titan.
After we've submitted all of the material we developed to try to prove to NASA and the review panel that we felt Dragonfly was, going to be a successful mission, we had to wait several months for the NASA associate administrator, all of the leads of the different divisions, to review all of the materials, look at the recommendations, and they were choosing between 2 missions at that time. So we were semi-finalists. We found out few days ahead of time when the announcement was going to be made. And I remember it very distinctly because I was at a scientific conference, and it was the astrobiology science conference. They set up big TVs in the largest, like the ballroom at the conference, and everybody at the conference came in and, didn't know what the answer was going to be. And up on the TV, we had the administrator at headquarters, and then it was very dramatic. It was very made for TV. And then they said, and the next
New Frontiers mission, Dragonfly.
The whole room, like it felt like everybody jumped out of their seats and was like screaming and cheering and so excited and hugging and all of these things. And then I got to go up on stage with some of the other team members and you know, make a little bit of a speech, just talking about how excited we were about the mission. It was like my own version of an Oscar speech. As a scientist, that's probably the closest I'll get to that. But it was like truly magical. It was a truly magical way to learn that the mission was selected.
So Dragonfly is the size of a Mars rover. It stands, you know, about this high, and it's about 10 feet long. So we're used to drones that are, you know, small things that we fly around in our backyards. Dragonfly is really a Mars rover-sized drone that will be able to fly from place to place on Titan.
The atmosphere is dense. It's about 1.5 times the surface pressure of Earth. There's a low gravity. It's about a seventh the gravity of Earth. And so that actually makes it really favorable for the kind of heavier than air lift that you get with you know, a drone or a helicopter type flight. And so the mission is designed to go and visit several locations on the surface of interest. That includes the equatorial dunes, which we think have a lot of these organic sand particles, and also a former impact crater where there had been liquid water in the past after the impact, but it's since frozen over. But we want to know, you know, what kind of chemistry took place in that location for the time when you had the liquid water present.
But this drone idea with Dragonfly is going to be extraordinary, and it's going to look for all kinds of biosignatures and other components that we can find on the surface, because the Huygens probe was not designed to land. But this time we're landing and we're going to get the information we need about the composition of Titan's surface. What is there exactly on the surface? And how does this translate into the features that we see on the surface?
About a decade from now, we'll be getting ready, hopefully, for its landing and figuring out how to navigate the surface of Titan remotely. So when we get the first images back from Titan, it will be one relief. Okay, we did it. We landed. And then I think it's going to be just, wow. And what's that? And what do we think that is? I know to expect the unexpected. I keep telling everyone on our team, every time we talk about this, no matter what we plan for and no matter what we expect to measure, we're going to get there and it's going to totally change everything. And we're going to find something that we didn't expect. And we're going to have to, you know, pivot and think about things in a whole new way. But again, that's the fun of it. And that's why, you know, you want to go and you want to go with all the best tools that you have. And then you have to be ready to react to what you find.